Welcome to the eLab Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss. I'm the Managing Director of eLab of RWTH Aachen, and today I'm delighted to welcome Dr. Kai-Philipp Kairies to the eLab Innovation Podcast. Dr. Kai-Philipp Kairies is the CEO of Accure Battery Intelligence and thus a renowned expert on battery data monitoring. So today I'm thrilled to deepen my understanding of the field and looking forward to the conversation.
And what we basically do is for each individual battery, sometimes on cell level, sometimes on module level, we build aging models in the cloud. And all of these individual aging models then inform the individual operating strategies. And with that, so we have it rolled out for 150, 200,000 packs at the moment. And we see that we can get, there's always a pretty broad range of how much you can improve because all systems are different, but generally between 20 and 30% lifetime increase.
All right, Kai-Philipp, great to have you here. Looking forward to the conversation. Today's topic, safety, performance, and lifetime. Before we jump in to the topic, I would like to ask you about a personal question, how you made it into the field of battery and what your path was. So maybe you can give us a little insight.
Yeah, sure. Actually, it happened not too far away from here. Back in 2008, I was a student here at Aachen University in electrical engineering, and like most other students at the time, probably, I was considering to, stop studying because it was so frustrating and so difficult, and Aachen is not a great place for doing your bachelor's because it's really difficult. I mean, that's also a reason to do it here, but it's a really tough
it's challenging,
experience,
right? It pushes you.
And especially in the first part of, university, there's not a lot of application around, so it's all very theoretical, and you're asking yourself, why am I doing this? And, it sounds like a fantastic story, but it's true. By chance, I got into the lecture of a new junior professor who started 3 months before, who gave a lecture on batteries, and that guy's name was Dirk Uwe Sauer. And as you know, he, eventually became my supervisor for the PhD, and I worked many years as a chief engineer for him later on. But yeah, that guy...
During your time at ISEA, right?
Yes, absolutely. And so that guy really turned me to batteries. And he got on stage and said, look, the only thing we need for a successful energy transition, we have solar figured out, we have wind figured out, grids for hundreds of years. Storage is the only bottleneck for clean energy that we have today. And you can work on it with me. I was like, okay, signing up today. I got a job 2 weeks later at his chair. That has been 15 years ago, and I've been working on batteries every day of my life since.
That's crazy. Yeah. That's really cool. So, but eventually at some point, you departed from ISEA, right?
I did.
And then you funded your own company, and that is Accure Battery Intelligence.
That's right.
So maybe we can, look at that for a moment. So what happened at the point where you said, okay, time at ISEA is over, looking into the new opportunity. So what was that about?
Yeah, the people that don't know ISEA, it's one of the largest research groups on battery systems in Europe. And as chief engineer, I had the privilege to work with many different companies in the battery space, from automotives to energy companies to basically all these companies that starting in the 2010s were moving into batteries, e-mobility, stationary storage. I had in some shape or form projects with, right? Yeah. Consulting projects, R&D projects. And so I was, fortunate.
So the whole bandwidth.
Yes, absolutely. And I was fortunate to get quite an intimate knowledge on where the industry stands, where it's moving, and also where there are some, challenges left.
Yeah.
And one of these challenges that I saw that was not properly addressed was the whole part of digitization around batteries. And actually, I tried to work with companies on such projects from an R&D side and sell them research projects. Hey, digital batteries, this would be cool. And the response from the industry was like, yeah, maybe in 2 years, this is not a topic for us now. And I thought, wow.
What did it mean back then, digital batteries? Like when you wanted to sell something, like how do I understand that business
So the
case?
one thing that's really interesting about batteries, lithium-ion batteries, is every lithium-ion battery is an IoT device, right? It's an Internet of Things device because it has sensors and it has a small chip, the BMS, the battery management system, that just continuously generates data. And no one was using that data for any meaningful purposes.
Yeah.
And I always thought, what a waste, right? There's so much value in this data, in terms of safety, in terms of performance, lifetime, that no one was leveraging. And after, I want to say I was unsuccessful in setting up research projects with companies, I thought, well, this is going to happen. And so we started a company to build a solution and then, address the industry when they're ready. That was 3 years ago. And I would say our hypothesis turned out to be true.
And we will see a how in a bit and discuss a couple of example cases, hopefully also. So that was then the point where you founded Accure and made it a business. And as far as I heard, you're also growing, right? So it's not a very small startup anymore, but a decent one already. So
we've grown to about 70 people around the globe. We now have customers on 6 continents. And all in all, we're managing today probably about 600,000 battery packs, 2.5 gigawatt hours of capacity. And it's going to be much more actually in the next few months. Our US operation is kicking off a lot, and the IRA, the Inflation Reduction Act in the US, is really boosting everyone's business right now.
Okay. Before we go more in depth on the current state of the market, let's look at your business model a little more specifically. So what is Accure really doing? Because I think it's very, very interesting to really understand how you are able to address safety, performance, and lifetime with one company.
Yeah, it's all in the data, and we're basically the facilitator to leverage data that companies already have and get more value out of it. So the way that we operate is most companies already have their assets connected, whether it's an electric car that has OTA or it's an energy over-the-air capabilities. So they're basically connected to the internet. Or if it's a battery storage system, trading next to a wind farm, it's also connected to the internet to get control signals. Charge now, discharge later, and so all of these assets, they're online. And most of these assets already share BMS data with the cloud. So we have petabytes and petabytes of battery data in the cloud already today. And we as Accure, we're basically a highly, highly specialized.
So just a petabyte is 1,000 times a terabyte.
Yes.
Right. So
yes.
and then giga, tera, it's big.
It is really
huge,
really big.
To be honest.
And if you think about it from a data perspective, we're looking at time series data, typically in the range of 1 second to 60 seconds.
So it's very granular.
Yes, and if you think about some batteries have single cell voltage measurements. Also the data in the cloud. And, for an electric car, that could easily be a few thousand voltage measurements every second.
Yeah, for every cell then.
Plus temperature, plus current.
Yeah.
And so we're looking at easily, 4 to 5 digit numbers of values per time interval, which could be a second, over 10 years for one asset. And so this is actually one of the reasons why many traditional battery companies are not doing everything themselves. This is a very, very difficult challenge. Just
to
from
deal
a
with
data
all the data,
perspective. Yes.
I mean, the one thing is to have the data,
Yeah.
and then the other thing is to really being able to operate with it and to get value out of it.
Absolutely. And I mean, we both have some experience with BMS. BMS sensors, they're not great. They're cheap. So whenever you build a BMS, you define what's the minimum requirement, and then you optimize for cost. So whereas, modeling typically is based on lab tests done with high quality sensors, high quality equipment, what we need to work with for analysis.
So that equipment that we use there is not the equipment that is built on a chip on the BMS.
Absolutely not.
That's the important point here, right?
Yes. To give you an example, we regularly see the current measurements with errors of up to 30% in the lower range of the operating window. So a 100 amp current sensor, when it's measuring 5 or 10 amps, it could be 30% more or less.
Yeah.
And dealing with that at scale and with thousands of different BMS setups that all have different sensors and all have different data logging techniques, this is quite an infrastructure that you need to build and maintain before you can even think about doing actual analyses.
So the one of the core competencies then, as I understand you build, is really the data acquisition procedure system, you could even say. I mean, in a lab, it's also that data is also challenging, but it's in a very controlled environment, right? Yes. You know your boundaries, etc. You then have one procedure perhaps, and as you already touched on, you build up, or you acquire various types of data from various customers. They're perhaps all in different format, all in different even file types, or
absolutely,
so CSV files or whatever it may be. So that is the first part on acquiring this data, structuring it,
normalizing it, cleaning it. Really.
Cleaning it, okay.
So we apply individual models to reverse engineer the error out of measurements, right? If we have certain shunt or other types of current measurements, from experience and from data, we know how to fit models to find the true value behind the measured value, right? So there are systematic errors, an offset or an amplification error, and they're different for every module. Even if you have 1,000 batteries of the same type.
I was going to ask you, what is generally a good sample size that you need in order to reverse engineer? But if you're saying it's already on a module basis, your sample size is rather small. So your algorithms must be quite sophisticated in order to be able to predict or to reverse engineer based on so few input.
Yeah, so the way that we typically work is we build, I want to say, broad ranges of a certain module type. And we know, this sensor, for example, has an offset. And we know all of them have an offset. But individually, it will always be slightly different because it's calibrated, and sometimes it's not calibrated.
Yeah.
And so if we apply our algorithms, we know, hey, use the smart offset finding feature.
Yeah,
for all these
so one
modules.
of your products, so to speak, right?
Basically. And this is at the very beginning of the tool chain. And we also know that the offset changes over time.
Okay.
Right? So you need to recalibrate. And so this is really a lot of legwork before you come to the fancy part.
It. So the question there that I ask myself right now is, and I don't know if you can talk about this in detail, but how automated can that be? Because it sounds like detective work that a programmer then has to do, dealing with all that data, or a data analyst has to do, dealing with all this. Is really Automated, or being able to be automated, yeah.
I would flip the question. How manual can it be if we're working on 600,000
Sure.
parts?
Yeah,
So,
but maybe on a conceptual level where you just understand the general structure of the data that you have there at hand. And is there still some manual task before you enter all the algorithmic stuff, or?
No. So the way that we operate is really we have generic algorithms for all the different tasks that we do. And if we onboard a new data set, we will run them, sanity check the results, with engineers.
Yeah.
And if we see, wow, there seems to be something that doesn't work, we will add a feature to the general algorithm.
Got it.
So that it can also in future catch similar things. But the way we typically operate is we run updates every 24 hours for all of our systems. And so it's not possible to do that manually.
Got it. Okay. Wow. So that is then specifically that the customer also sees. I think what we just talked about is mainly running in the background. Yeah. Everyone has an idea that it must be quite complicated and a lot of programming, a lot of engineering involved there. But what is really the value that you bring to the customer and talk to the customer about, hey, this is what you will get? So maybe touching on safety, performance, and lifetime in a minute, but leading there.
Yeah, no, but also one interesting thing is, we as a company, we have very different customers.
Okay.
So some of our customers are German automotive. I'm not allowed to name who, but they're really sophisticated and they have their own battery intelligence teams. And so we basically supplement them with stuff that we can do that they haven't figured out. And this is, on a very detailed level, we exchange information. And then on the other end of the spectrum, and, not meaning this in a disrespectful way, we have companies that don't really care about the details. Okay. Maybe it's a fleet operator of electric buses. Mm-hmm. They don't have battery PhDs on the team. Why should they?
Yeah, sure.
Right? So their interest in the results is very different. Mm-hmm. And for example, one of our customers is the Berlin Transport Authority. Mm-hmm. And they are switching to entirely electric buses by 2030, and then they will have almost 2,000 electric buses in their fleet. Yeah. And now, in the last years, there have been electric bus fires in Germany, in 3 cities, in London, in Paris.
Mm. Yeah, I think during the lecture Ring Mobilität, which we give, you also gave a talk and you showed a very impressive picture of, I don't know, was it a bus or something in Paris which catched fire? Yeah. It was massive.
Yeah, that was, and by the way, that was a so-called solid state battery.
Interesting.
So it was the Bolero system. Mm-hmm. And, they always claimed that it's impossible for them to catch fire. Yeah. And then 2 buses burned down within 2 weeks. Mm. So no high energy density system is inherently safe, whether it's gas or oil or batteries. I mean, it's just, if you pack a lot of energy into a small room, there is a risk.
It wants to escape.
Right. And so it's perfectly clear that nothing can be 100% safe. It's just about managing these risks. And we've done this, with many different technologies as a society. But so these, fleet operators, they don't want to speak about impedance changes or lithium plating. They want to know, safe, yes or no. Mm. Do I need maintenance? Yes or no. Mm. And so, you asked how our products look. For such customers, it's really a list of assets, green, yellow, red, and a call to action if it's yellow or red.
Yes. So they want to be told, okay, bring the bus back. It has to be maintained or just taken out of traffic immediately. Yes. And I think the cases that you made are already underlined that it's really necessary at some point. Not just for mobility, right? But also for home storage and other devices which use batteries.
Absolutely. And I mean, it's safety is always a delicate topic to talk because, we don't want to run around and make people scared of batteries. We want to make, batteries successful.
Yeah, I got it. because to put this into perspective, maybe batteries are, I mean, technologically speaking, they are unstable, but they can be managed using the BMS, of course.
Yeah.
And then from the customer's perspective, looking at it statistically also, batteries are relatively safe, right? Comparing them, for example, to ICVs, so combustion vehicles, the statistics point in a clear direction. But nevertheless, the cases, and we want to evolve as a society and also technologically, and then you are in place on providing the tools to operate this safely, right? So how does this look like on your daily business? So we know now how you procure or acquire the data, and then how you analyze it, and then that there are customers who want more specific information, like the OEM, or just wants a simple dashboard with a green and a red traffic light and saying, okay, you're good to go, or you need maintenance. So can you talk a little bit about use cases or some examples that show how you address the safety point on a daily basis?
Yeah, sure. Just one more example, like my favorite example when people mention battery safety. I think it's a very good proof point that most people believe batteries are safe if they carry a phone in their pocket. This would be a very bad place to carry something that's dangerous. And so I think, there are some outliers and we need to deal with them. But all in all, the industry is on a really good track.
Yeah.
And so to your question, how does that look? One of the beautiful things of working in batteries is they become relevant everywhere right now. So at Accure, we basically...
Which circles, just a little point, circles back on our motivation, also my motivation, right? To enter the battery field in the first place, because we see it
when did
everywhere.
You start?
A couple of years back, not as long as you, but 2016, roughly 2015. That's where I went into batteries,
Nice.
So, but I didn't want to interrupt you, but just understanding, like, batteries are everywhere,
And it will be much more, right? If you think about just the growth curves that we all know them. We have 30% year-over-year growth, and it's going to be so many thousand gigawatt hours of production capacity in whenever. And we look at these numbers and we're like, oh yeah, that's a curve that goes up. But if you just bring yourself into the situation of thinking, wow, everyone's overwhelmed today already. All the car makers, can't run fast enough. We can't launch products fast enough. And we should go to 4x of that in 5 years?
Yeah.
How? Who's going to do it?
Safely.
Right? And so it's crazy if you really realize on what trajectory the battery world is really on. And it will mean that more suppliers, younger companies with less experience will also enter the market. And we've seen something very, very similar in solar in the 2000s. If you just compare the growth of solar and battery and also the challenges that the industry had, it's almost identical.
Okay.
And it took the industry 20 years to mature to a point where now it seems like, a standard business. Building a solar plant is nothing fancy today, but it was 20 years ago. And I think the same will be true for batteries.
I think it will be even more relevant to mature the battery field, because don't want to underemphasize solar here, but batteries can be more dangerous.
Yes.
It's not that it will not operate, but it can do harm if it does not operate correctly.
Absolutely. Right? And, they are more complex from an asset perspective. A solar panel is basically, unless you have a storm, a hurricane, or vandalism, the solar panel ideally lives for 20 years. If there's manufacturing issues, okay, it can degrade faster.
Yes.
But a battery, the aging so much depends on how you use it that the very same battery might live for 12 years or only 4.
I talked to Florian Ringbeck a lot about when is the perfect situation or the perfect state for battery and how. And you have calendaric aging, of course, and cyclic aging. And then those parameters are determined by temperature, for example, but also C rates, etc., etc., etc. And as you said, like we have stationary, we have mobile.
Yes.
Everyone uses his or her device differently, charges them differently, very important. Okay, and that makes it more complex.
And that's actually circling back. If whenever you have problems that become too complex to really oversee them manually, that's where data comes in and where data automation comes in. And this is actually also one of the things that we do with our customers. If you have a multitude of battery suppliers, form factors, chemistries, now everyone is using LFP in stationary. 3-4 years ago, it was NMC.
And LFP was said to be dead.
Yes, 5 years
and now
ago,
it's coming
people
back
said,
even stronger.
It's a winner-takes-all market. NMC is going to win it all. Completely wrong.
Yeah.
And I think that the error that these people made in their estimations was they underestimated the overall size of the battery market, right? Because in the size that we really have, multiple technologies can be scaled up and have synergy effects and the effects of scale. And that's basically what we saw on top of a supply chain crunch. And thinking about optimal usage, lifetime, the only way to do that in a meaningful and effective way is through software. There's not going to be people making decisions and, grabbing a telephone to call the site, stop discharging. It has to be automated.
Cell 566 in your battery pack and needs to be replaced.
Yeah, but the thing is, even that would be an upgrade to what's done today.
Currently done, yeah, okay.
Today, it's like no one knows what's going on.
So people or even the manufacturers of electric vehicles, they really rely on the quality at leaving the gate of manufacturing, right?
Yes.
And I think also referring back to the podcast I did with Florian Ringbeck, we know that it's not the case that a cell will have a very predictive lifetime. So there is a variance in each and every production, even in the same batch. Even as you also pointed out in our discussion prior to recording the podcast, even for the same batch that is operated under same conditions, you see divergent charging and discharging curves. So
everyone should read Thorsten Baumhöfer's dissertation where he did all the measurements. It's a great piece of work.
It's from Isaiah, right?
Yes, and I think this famous chart that he has in his dissertation, it shows that towards the second half of the lifetime of the batteries, he cycled 80 cells, identical cells. He measured them before to be as close as humanly possible to each other, and then operated them under the exact same conditions, same temperature, same cycles,
lab environment,
highly, highly controlled. And towards the second half of their lifetime, the spread of the capacity between the cells is 30%. Right? This is crazy.
This is
so
automotive cells.
I'm confident that the spread will be slightly less for automotive cells, high quality, good pack design, balancing mechanisms. So there's a few things that you can do.
Optimization in electro manufacturing, etc.
Absolutely.
Today there are many measures that are taken.
But a substantial spread over the lifetime will always be there. And I mean, just think, not every car is used in the same way.
Yeah.
So you have a substantial spread, even if they would all be used in the same way, but they won't. So it's going to be an issue, always.
Yes. Gotcha. So, and that brings us back to your business model saying, okay, we need a active control, like a safety control system, but also, and that maybe brings us to our second key point, a performance control, right? Because safety is important, but let's assume we have safeguards in place by means of your products and services or others. What else is there that you can offer for customers that allows because in the end it's all about cost and the economic viability. So that brings me to performance. So what can we do in order to improve performance, and what can you bring to the table there?
Yeah, so performance has a few different flavors. One that is pretty straightforward, is contract management. Whenever you buy a battery from, whether you're an OEM that buys cells from Samsung or CATL, and then you sell a car, or if you buy a bus fleet from a bus manufacturer, you will get, certain contracts with your battery, like a warranty contract and a performance contract. The performance,
which will include like cycle numbers, calendaric lifetime, or what would it include? Just to give
a warranty
general
contract
understanding.
In automotive, warranty contracts are typically like 8 years or a certain number of kilometers. That would be very easy. If we look into B2B applications, so business to business, when not a private person buys a car, but maybe a transport authority buys 100 buses. The warranty will be a little bit more complex and more detailed. So it might say these buses can run for 200,000 miles unless they're operated in a certain way that will make the warranty go away. If you abuse them, we can't guarantee anymore.
Yes.
And so one thing that is really, really challenging for most companies today is to find out, is my asset still covered by a warranty? Did I not use it in a way that might be harmful to my contract? It's hard to track it. Do I have a warranty case? Do I maybe have already a claim against my supplier because the battery is not doing what the warranty says? Because if you have 100 or 100,000 assets, checking each contract individually against the performance, that's difficult.
Yes.
And software can really unlock clarity on, hey, am I getting what I paid for?
Or is it a warranty case?
And if it's a warranty case, would I be successful in claiming it? Or can my supplier say, oh yeah, your warranty went away on the second day because you overcharged? And so these are pretty straightforward things that don't require sophisticated prediction models that add a lot of value.
Okay.
And one example I can tell you...
So it's a low-hanging fruit for everyone there.
Yes. And one example I can tell you just from this month is we supported a large-scale storage owner and operator in the commissioning phase of their system, right? So they have a big asset in the US that was powering up, starting to work on the market. And we did an initial analysis and were able to show them, hey, some of your strings don't perform.
What do you mean with strength in this case?
So in a stationary battery system, you typically have racks. So 19-inch racks like with servers. And then you have maybe 10, 12 modules stacked on top of each other. And the one rack might be called a string sometimes, and a few strings can be called a bank, and then you have several banks in a container. So it's cell, module, string, bank, container.
A little bit different than in electromobility.
Yes.
The terminology there. Okay.
And the interesting thing, like in e-mobility, typically all the strings, so all the modules in a string are connected in series. So if you have one weak cell, it will limit the performance and capacity of the entire string. And so we were able to show our customer that a few modules were faulty, affecting the whole string, and therefore the system would not bring the outcome they predicted.
Maybe if I may ask the question there, I forgot to ask it for the safety part. On what time frame, on what time base are we talking? Or is it like for the safety case, it's really relevant, I assume. So are you able to, within, let's say, minutes or hours, to tell like, hey, there's a safety case, or like we're talking now about performance, there is a performance case, you have to act. What time frame is that?
We're talking about weeks, actually.
Okay.
I can give you one example.
In this case, weeks, but for a safety...
Yes, weeks. And that's the interesting thing about it.
Okay, explain that.
Yeah, so we're using pretty sophisticated electrochemical models to find internal states of the battery that we know are correlated with failure.
Yeah.
So for example, lithium plating. If we see excessive amounts of lithium plating, that can lead to a short circuit or to gassing or many other things. Yes. And so if we see the plating going up, we can already warn that this cell will be dangerous, although
In weeks.
yes.
Wow.
I can give you one example. So, safety is a very sensitive topic. So most of our customers, are not open to sharing anything at all, which is, of course, understandable. There is, however, one case that was pretty public and where the customer decided to be proactive about it after experiencing some fires to say, hey, we're now taking care of it. So, and that case was in home storage systems. The company is called Senec. They're a daughter company of Energie Baden-Württemberg, NBW.
Okay.
And so in March of 2022, they have a fleet of about 90 to 100,000 distributed storage systems across Europe. They're big.
Wow.
Each of them with like 8 to 10 kilowatt hours.
Okay. Like a normal home storage
Yes, right.
device.
And so in March of last year, within 2 weeks, they had 3 explosions in their portfolio,
Okay.
which of course was, really bad. No one got severely injured. There was property damage, but it was a really bad look, right? And so I think they reacted in a very professional and safe way. So the first thing they did is they shut down their entire fleet to evaluate what's going on. And as part of that evaluation, they pulled us in and said, hey, Accure, we have a lot of historic data. You have safety algorithms. Let's work together and see what we can do.
Yeah.
And based on that analysis that we did in 2.5 weeks, and they have 8 years of historic data, 3 different cell suppliers, a lot of complexity. And we were able to show that in all 3 cases, our algorithms would have identified the critical batteries at least 1 week before. In 2 cases,
Okay.
it was actually 3 weeks before.
Wow. So it's not that once you spot a fault that, we have to take the telephone or write an email, whatever. We really have to act because you already know much in advance. Okay.
We would still advise all of our partners to act immediately because, the statistics that we have on these failures, they're relatively low. All in all, we have pulled almost 50 batteries from the field so far, and we analyzed most of them, not all. And in all the cases we analyzed them, we were able to see that really there was a fault with the battery, whether it was from the electronics or from the cell connectors or from the cell or from the pack and these things. But the lead times, how much longer between our alert and the fire, of course, we can only see them if something happens. So we can only do that with customers that come too late.
In hindsight, yeah.
Yes, in hindsight. And for I think it's 8 or 9 cases that where we had this data, it was the shortest we ever had was 6 days, and the longest we had was 3.5 months.
Wow. Okay, so I think that this is very positive. If we look at it, that there is such a long lead time, that makes the case on battery safety even more, convincible towards customers also. Yes, batteries are dangerous because they are high in energy. I mean, every battery has the energy density of a bomb. Basically, it's only that the energy release is very slow.
Yes.
If it happens, it can be a bit dangerous, of course. But taking your example there gives me hope that we will have in terms of safety everything covered that is coverable by means of engineering and technology.
I think it's one layer, and I think it's one additional layer that's not standard today. But of course, I hope that it will, find some market usage.
Yeah.
The important thing, that I always want to stress is it's not the only solution, and it can't be the only solution. The 3 things that we really need for safe batteries is high production quality, resilient system design, and data analytics. And the first 2 are equally or even more important maybe, but adding a digital layer really has many benefits. Safety is a big one of them, plus all the other things.
Yeah. So safety, performance, we talked about.
Yes.
what is there in terms of lifetime with calendaric aging, cyclic aging? For our recording, we talked about the use case for potentially second life batteries. Yeah. So what is to gain there?
Yeah. So, I mean, probably most listeners of this podcast will know that batteries have pretty complicated aging mechanisms, and depending on how you use them, even, path dependent. So if you, it's not just I have some cyclic aging and I have some calendar aging and I just do a superposition and then I get to the result, like depending on whether you do calendar aging first and cyclic aging afterwards or flip, you will come to different results. Oh, so it's a really painful thing to model battery aging. But the upside of doing it well is so large, because when you fully or to a relevant amount understand when a battery ages faster, then you can make small changes to the operating strategy and avoid those very harmful operational points.
Like discharging very deeply or storing under high temperatures. Those cases you mean, or?
Well, from an aging perspective, for lithium-ion batteries, generally, higher state of charges are typically more harmful in terms of degradation. Deeper cycles with higher current rates, especially charging with higher current rates. But there are actually more subtle things, like there might be phase changes in the battery when cycling through. And if you do a 10% depth of discharge cycle at 50% or at 70% or at 80%, it can have dramatic different aging outcomes. And what we're basically doing is we're building...
Maybe if I can interrupt there. This may be really relevant for, maybe not for electromobility or like private electromobility, but for systems where you really have a high repetitive pattern,
absolutely.
where you can plan, where it becomes a business model even. There things become really relevant, and also from an economic perspective, good opportunity, right?
Absolutely. And we see really that the interest for these things is highest where the company really sits on the risk of the battery aging, right? If you plan the operation of a forklift or an electric bus or a big battery that trades solar, if you plan that for, say, 15 years, and then your battery dies after 8, you have a big business problem.
Yes.
And so these companies are, it took them a few years to figure out just how to build a battery. So, there's a certain steps you need to do in terms of maturity, like, hey, we need to build a battery. Okay, now it's working. Now we figured out we built it in the wrong way. Now we build a better version of it. So now that's covered.
So that's the design. We had those three things, right? The design, the manufacturing, which comes after, and then the operation and monitoring. And
it takes a little bit of experience from a company perspective to think about, okay, what are we going to do in 5 years? But now we can see really that the market is coming to this point where people asking questions of, okay, who is taking care that my plan really will become reality? What can I do to do that?
Yes.
And again, a digital solution is just the typically most cost-efficient way to deal with it and scalable. And what we basically do is for each individual battery, sometimes on cell level, sometimes on module level, we build aging models in the cloud. And all of these individual aging models then inform the individual operating strategies. And with that, so we have it rolled out for 150, 200,000 packs at the moment. And we see that we can get, there's always a pretty broad range of how much you can improve because all systems are different, but generally between 20 and 30% lifetime increase.
In terms of used kilowatt hours, so cycled kilowatt hours, or what is your baseline there?
It depends a little bit on the use case. For some, it's really just they need to they need to pass 10 years because our customer is the seller.
So the
and they
warranty
gave a
case.
10-year warranty, and they're just only interested in getting over 10 years. And when we work with...
and after it collapsed like a sprinter or a marathon runner at the finish line.
Well, and on the other hand, if we look at owners and operators who are just interested in getting the most out of it, throughput is the much more interesting value.
Okay. And can you talk about numbers that when we talk about lifetime increase? So I'm a customer now. I have an electric vehicle and I have a home storage device. What can I expect in leverage for those two use cases, which I think are relevant for every one of us at some point in the future? So let's just have a look at it.
Yeah, so for both applications, the flexibility you have in making adjustments is on the charging side, right? So typically, the sun shines most days between spring and fall. The sun produces more electricity through the PV panel than the battery can hold. So you have some flexibility in when do I want to charge my battery with which currents.
So that it does not hold too much energy or like full capacity over a very long period of time that is unused.
For example.
Right?
And also
Because
managing
that would
the
age the
charging
battery
currents.
more quickly.
So you basically look into this individual battery. What does it suffer most from? From high charging currents or high state of charges? No? And then you basically have a cost function. And then you can optimize. And one way that you would do it is you would, instead of charging the battery very quickly to its full state, you might delay it or slow the charge down. That depends really on the individual cell chemistry. The same also goes for electric vehicles. So most people, the scenario that everyone thinks about is, I get home at 6, I plug it in, and then the battery charges. And the question is, does the battery need to charge anyways? If you come home with 90% in the tank, it might be the best case to not charge at all. Or if, we're going into, a smart version where it syncs with your calendar and your car app knows you need to travel a long way tomorrow morning.
I think people are underestimated. If I'm the customer and thinking about very intuitively, I think I would expect that this must be the case, that if I can charge full, but I think people are underestimating the predictability of their daily habitual life.
Yes. People hate to be predictable, but they really are.
Yeah, that's also what Professor Sauer last week told us. Yeah. He also made the point there. Okay, so in terms of lifetime, we can increase it, and not just from an economic point of view, but also looking at a little bit more idealistically from the CO2 equivalent per kilowatt hours, right? I think that the biggest leverage that we have, not talking about sustainability of batteries, is not replacing the material or improving, even though we would wish it would be so easy, improving the manufacturability of cells, but increasing the lifetime, right?
Absolutely. I mean, you have basically a constant set of CO2 emissions during production. Yes, we can improve that over time, renewable energy and many things.
Yes.
But once the asset is produced, we need to use it to the
and there are physical boundaries, right? That we cannot exceed. We need a certain amount of energy for production and for mining as well, for the active material. And then, but go ahead.
No, and I mean, once we have a battery asset produced, we need to use it to its fullest extent possible. And we talked about Second Life when we were down in the eLab a half hour ago. I think that for some applications, it can really make sense. It will be challenging economic business models for some. My first guess would be to, if a car gets down to 80% of its range, well, just sell the car to someone who's happy with 80% of the range, right? So there's the vast majority of people don't drive much more than 150 kilometers regularly.
Again, this thing of predictability.
Yes. And I think that once we have a higher share of electric cars and people get a real life feedback of, hey, I've never run into capacity problems with my car, maybe I can get the cheaper one next time and save 10,000 euros.
Or buy the one used with a capacity of 80% that's
Right.
left. Yeah.
And so, and then actually this is an interesting segue into, well, how do I know that the battery has 80% capacity when I buy it?
There's your business case again.
Right? And there will be the need for a mediator because end consumers, they cannot even, PhDs like we are, oftentimes we're having trouble to estimate the SOH of a battery. How should a private person do that? And there's some interesting models where you can...
By the way, I know someone who we both know who did some little programming on his electric vehicle to find out his state of health of his battery pack. Just a side note.
Was it successful?
Huh? Yes.
Awesome.
But he's knowledgeable, Anyways.
Yeah, and I think these are all, this is out 4 or 5 years. I don't think it will be a relevant topic in the next few years because there's the incentives are to buy new cars. So the used electric car market is pretty challenging at the moment. But in a few years, there will be the need for it. And if you already, have the data in the cloud and you can run the analysis, you don't need to go to a workshop to have it tested.
Yeah.
That's a no-brainer.
Just look at your smartphone, okay. Yeah. Those eBay or whatever, like apps where you can buy it, okay, it has this rest capacity. It's proven by some authority, some mediator, as you say. Yeah, nice. So good times ahead, I would say, in terms of safety, performance, and lifetime, or?
I think the whole battery industry is moving in a very exciting direction. It's great to be a part of that.
Great. Yeah, looking forward into the future. And to our next conversation then, talking about the current state and your development with Accure as well.
Awesome.
Thank you, Kai-Philipp. It was fun.
Thank you.